Good evening, or good morning, or good night, or whatever. This is anyway homework 8, and we are in exercise 1. And we have a setup where we are tossing a coin, and we assume that this coin is fair, so we set H0 to be a fair coin, and H alternative, the alternative hypothesis, is set to be that the coin is unfair. So if P is the probability that the coin shows head, then H0, the null hypothesis, will be that P is 0.5. Because then it's equal probability that we get head as tail. And the alternative hypothesis is that P is not equal 0.5. In exercise 1b, we are asked to compute the probability of the sequence 1. The sequence 1, which we are going to refer to later on also. So what is the probability of first head, then head, then head, then tail, then head, then head? Well, that's nothing else but the probability of head first times probability of head times probability of head times probability of tail times probability of head times probability of head, and we get 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which is 1 divided on 64. When H0 is correct, we are throwing with a or we are tossing with a fair coin. So then we are asked to find the probability of another sequence, namely H or head first, then tail, then head, then tail, then head, then once more, first head, then tail, then head, then tail, then head, then tail. So we have written up the probability here, and then we have to take the probability of first head times probability of then tail times probability of then head times probability of tail, and so on, and we get again 1/2 in the power of 6, which is 1 divided on 64. So this sequence have exactly the same probability to be realized as sequence 1. See, here we are asked to count the number of different sequences we can get when we tosses a coin 6 times. When we toss the coin first time, we have 2 possibilities. So we have 2 possibilities. But then we toss a second time, and then we get, because we now have new 2 possible outcomes, we get totally 2 times 2 equal 4 total outcomes on 2 tosses, and the 4 total outcomes are head head, this path, head tail, tail head, and tail tail. That's the 4 possible paths after tossing 2 times. And then we toss a third time, then we get 2 times 2 times 2 equal 8 possible paths. And of course, total possible sequences in 6 tosses is 2 times 2 times 2 times 2 times 2 times 2 equals 64. In D1D, we let x be number of heads in n equals 6 tosses. Number of sequences that are just as surprising or even more surprising than the sequence in 1 is. Then we have to think which possible sequences this is. Well, it's all the sequences which have just one tail, and that's the sequences 1 to 6, written down here. 1, 2, 3, 4, 5, 6. And the same is when we just have one head. That is just as surprising as having one tail. So we get new 6 sequences. And even more surprising than the mentioned sequences are that we get 0 tails, which are 6 heads, or 0 heads, which is 6 tails. So, with mathematical notation, we got total combinations 6 over 5 plus 6 over 1 plus 6 over 6 plus 6 over 0, which is equal 6 plus 6 plus 1 plus 1 is equal 14 possible sequences. E, assuming that H0 is true, compute the probability of getting a sequence that is as surprising or even more surprising than 1. Okay, we are now working with a binomial discrete variable, and remember that the probability mass function for a binomial discrete variable is on the form f of x equal n over x times p in the power of x times 1 minus p in the power of n minus x, where n is the number of trials, tosses in our case, x is the number of successes, heads in our assignment, and p is equal probability of success, which is equal to half under h0. So in our assignment, this gives that f of x is n equals 6 over x times 1/2 in the power of x times 1 minus 1/2 in the power of 6 minus x. But here we have the same base, 2 places, so I can combine this. So I therefore get 6 over x times 1/2 in x plus 6 minus x, which is nothing else but 6 over x times 1/2 in the power of 6. And then it's more easy to calculate the probability of getting a sequence that is as surprising or even more surprising than 1, where 1 is the sequence head, 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 tail, head, head. And this is equal that we get either 5 heads, or 1 head, or 6 head, or 0 heads. And the probability of getting 5 heads, this probability is this. 6 over 5 times 1/2 in the power of 6. Just using the formula f of x above. The probability of getting 1 head is 6 over 1 times 1/2 in the power of 6. And the probability of six heads, or 0 tails, if you want to see it like that, is 6 over 6 times 1/2 in the power of 6. And 0 tails, the heads, 0 heads are 6 over 0 times 1/2 in the power of 6. And then I just factorize 1/2 in the power of 6 outside that parenthesis. And then we have that 6 over 5 is 6, and 6 over 1 is 6 because of symmetry, and 6 over 6 is 1, and 6 over 0 is 1. And we get that the probability asked to compute is 14 divided on 64, which is 7 divided on 32, which is 0.21875. So we do get one of these 14 sequences pretty often. Actually, in 21.875% of the so because we do get one of these 14 sequences pretty often, I do not think that setting the limit for rejection, rejecting H0 to getting a sequence that is as surprising or even more surprising than 1 is smart. Because then the probability of rejecting H0 wrongly, when it's true, is 0.21875 equal 21.875%, which is too high, I think.